So we can sort out a lot of these problems by using the one that is a catalytic converter that you often have on the exhaust pipe of cars nowadays. How do they work? Well, I'm sure you would have learned the equation at GCSE. You take carbon monoxide, you react it with nitrogen monoxide that's coming out of the exhaust pipe, you pass it over a catalyst, that shimmies everything around to give you N2 plus CO2, and you need a half N2, like so. So carbon monoxide gas reacts with nitrogen oxide to give you nitrogen gas and carbon dioxide gas. So we've taken two quite nasty pollutants, we've turned it into nitrogen gas, it doesn't harm us, and carbon dioxide as well. So we've removed the carbon monoxide and nitrogen monoxide coming out of the gases. How does it work? Well, there are a few stages to that. You do have a little picture on your summary sheet. Let's see if we can do it. So what you have is you have a solid catalyst. So if this is your surface of catalyst, what happens is the molecules come along. So along comes my carbon monoxide. So carbon monoxide, it's actually got a triple bond there. And then I've also got nitrogen oxide. What they do is they form weak bonds with the surface of the catalyst. When we do that, we say that they have been adsorbed. So this is the first stage, and this is adsorption of gases onto catalyst. What's happening here, if it's forming a bond with the surface of the catalyst, as it forms this bond, and using the electrons to form that bond, what do you reckon is happening to this bond between my two atoms here?
It's becoming weaker?
Yeah, it weakens the bond, so we can say the bonds in the molecules weaken as the electrons are used to form bonds to the catalyst. So because it does that, as it weakens these bonds, what's it going to lower in terms of your rate of reaction? That lowers the, what's that barrier to get things to react?
Initiation energy.
Almost.
Activation energy.
Activation energy, yeah. That's going to lower my activation energy. So this lowers the activation energy. So the next step that happens is reaction. So that's my surface. What's going to happen? I need a few more molecules knocking around. But reaction happens. So I form N2 and I form CO2, like so. So they react. So we can say here the molecules react to form products. Like so. But the key thing you have to now do is get these off your catalyst. It's no good if they just sit there, because they're blocking my catalyst if they just knock around. So the final step is the molecules, and there's a special word for this, and that's called desorption. Desorption occurs, the molecules leave the catalyst. So off they go, N2 and CO2 shimmy off out of the exhaust pipe, like so. So, adsorption, bonds weaken, reaction, desorption. And that's how your catalyst works. Okay, so there's key things. You've got to think carefully about finding the right catalyst is quite difficult because you want these guys to form strong enough bonds to get them onto the catalyst, but you don't want these bonds to be so strong that they don't leave, because if these stay around, they block your catalyst, so it's no good. So does anybody know what type of catalyst this is called if you have a solid catalyst and gaseous reactions? You know what it's called? Heterogeneous catalysis? Where you have the catalyst in a different state to the reactants is called a heterogeneous catalyst. So we looked at catalysts when we did rate of reaction, and we said it's like this guy who comes along at a party and helps people meet each other, yeah? So you could think of this as being like, you know, if you go to well, you don't obviously go to pubs, but if you ever did go into a pub, some of you may have been in one where you have a bar, yeah? This is like the bar, and this is like the barman here, okay? So you go off with your friends, you go in little pairs, don't you, to the bar, get your little drinks, so you form like an interaction here, okay? So that's forming a weak interaction, because this is like your meeting place. Yep, you're all meeting at the bar, it's a good little place, you don't feel like you're on your own, stuff like that. As you maybe have a beverage of some sort, you know, you get a little bit more relaxed, and you also start eyeing people up, also, at the bar, okay? So the bond with your friend weakens, because you kind of think, yeah, I'm going to ditch them, but you start taking an interest in perhaps other people at the bar as well, so that's lowered the activation energy to form in a new relationship. You then all move around and you form those new bonds, but it's no good to the bar if you're all sat there, because other people want to get to the bar, don't you? It's really annoying when other people are sat here. So that's when the bar person wants you to go, so that's when you all go off to have a little boogie on the dance floor and leave the bar to start again and introduce some more people to each other. Okay.